All right, sorry for the delay, everyone. Okay, the notes today are pretty short. The warm-up says a mass oscillating up and down on the bottom of a spring, assuming perfect elasticity and no friction or air resistance, can be modeled as harmonic motion. If the weight is displaced a maximum of 5 centimeters, find the modeling equations. If it takes 2 seconds to complete one cycle. Okay, so here is a diagram of what's going on. Okay, there are 2 sinusoidal functions that we've previously learned, and here are the standard equations of each of them. I'm going to select sine because sine hits at 0, 0, and I want to assume that the spring is at the origin when time equals 0. Does that make sense? Okay. Now, based on the information given, there is no phase shift and there is no vertical shift. So I can just use the basic form of this function, a sine of bx. We're given that the weight is displaced a maximum of 5 centimeters, so the amplitude is 5. And we're told that it takes 2 seconds to complete one cycle. So the period is 2, which means the frequency is 1/2. So using that information, we can figure out that b is pi. Now that we have a and b, we can plug that in. We get f of x equals 5 sine pi of x. Or 5 sine of pi x. Does that make sense? Yes.
What happened to the C over B plus B?
So, because the spring is just, there is no side-to-side motion, there's no up and down motion, it's just going up and down like this.
So it's just like there's no shifts.
There's no shifts that we have to worry about for harmonic motion.
Okay.
And this is going to be the case for any simple harmonic motion. You don't have to deal with any of those shifts. There will probably be a trigonometry word problem as one of the FRQs. Just giving you a heads up. That would be my guess. A lot of the practice exams have some kind of real-world situation that involves some kind of periodic motion. Yes?
So when we're looking at this question, like on the exam, like how would we know to use like sine or cosine?
Well, hopefully you can see from the description that this is going up and down, like there's some repetitive motion,
Yes.
and because we're assuming there's no friction, it's not getting smaller, it's bouncing up and down forever. Any kind of periodic motion, it's going to be either sine or cosine. And in many cases, you can use sine or cosine. But because this is starting at 0, I picked sine because sine hits at 0, 0. Whereas cosine hits at 0, 1. Yes?
Can you explain what the values?
The values? Okay, so once you decide to use sine, we need to figure out what a and b are. The amplitude is 5, because we're told that it's displaced, it's going up and down a maximum of 5, right? The period is 2. Period is how long it takes to complete one cycle, and it says here it takes 2 seconds to complete one cycle. And then using the equations we learned in the last unit, let's see here, this last unit's packet. There we are. For B, these two, and then those ones. You can figure out what B is using those formulas. I do recommend that you memorize these formulas. Amplitude's pretty easy. Period and frequency are just reciprocals of each other. Any other questions on this one? Yes?
Where did you find
B. Okay. So using this formula, I know that the formula can be found. What did I just put here? The formula can be found here. It's in 4b. I know the period is 2 pi over b. The frequency is b over 2 pi. I decided to use the frequency. You could use the period instead. The frequency is 1/2 b over 2 pi. Solve for b, you get pi. Sure. Any other questions on this one? All right. Example number 1. Describe the graph of f of x equals this in terms of a basic trig function. Locate the vertical asymptotes and graph 2 periods. Sorry, I forgot to ask, does anyone need more time to copy this down? All right. If you don't have any whiteboards, please send someone to grab some whiteboards. All right. There are 2 transformations happening here. Please tell me what the transformations are. So transformations are like horizontal stretches or shrinks, vertical or horizontal translations, and by how many units. Okay, so tell me what transformations are happening. I'll give you 1 point for each one.
It's okay.
Oh. Sorry, there's 3. I completely missed the +1. Yes. Sorry, there's 3. I'll give you 1 point for each one. Yeah, for some reason I missed the +1 here. Yes. 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 Okay, so 1, 2, 3. Great job, you guys. Yes. Once you get it right, please check in with your teammates. Make sure everyone understands. Ask each other questions. Help each other out.
No, we did geometry.
The horizontal one is incorrect.
That's not how it No, I'm gonna do it online.
So what you have, yeah, but there, like if you end up with a fraction, use the other one. Okay. Hold on.
I don't know. Yeah, exactly. You are so
It's not a shrink.
What? How does that make sense?
All right, here are the answers. It is a horizontal stretch by a factor of 2, a vertical stretch by a factor of 3, a vertical translation up 1 unit. You said a horizontal shrink by 1/2, which is a stretch by 2. Yeah, it's very close. Okay, I'm not going to count this one for a point because I don't know if I'd be able to judge it correctly, but I'd like you guys to try to graph this without a calculator. No calculator, graph it as best you can. And I don't trust my ability to judge this on a whiteboard. Let's see how close you guys get. So you need to graph 2 periods. Yeah, on the whiteboard. Or if you'd rather just graph it on your paper, and I'll show you what I got on my paper. You guys all know what cotangent looks like. Apply the transformation, see what you get.
Oh, okay, I see. And then I'll use like red. Yeah, you can okay, so you just stretch. Obviously, these aren't in the right spot. Oh, that's without this. Shift up or stretch it.
If you have to graph any trig functions on the AP exam, please remember your asymptotes and your intercepts. Asymptotes, intercepts, and like turning points, anywhere where you have maxes and mins. Those points need to be accurate, and then the basic shape. Other than that, I think you can get away with a little bit of mistake here and there. But the asymptotes and the intercepts and turning points, any other significant points, you have to have down.
How do you find the asymptotes?
Well, you know where the asymptotes and the cotangent are, right?
0.
Do you remember the graph of cotangent?
I guess.
The basic graph of cotangent?
It's the black one.
Okay, yeah. Well, that's...
I knew it's Y over S.
So tangent intersects 0, 0? Actually, the black ones are right. Yeah.
It's Y over S.
The red ones, right, are incorrect. That's tangent. Cotangent goes the other way.
Wait. What is the
Should we just go over it?
Yeah.
Okay. Is anyone close?
I was close. Give me 1 second.
There's more of them, but let's go over it.
I guess if I knew what those, like,
They're half. They're half. Or
half or pi over 2?
pi over 2.
How do I stretch these? Just keep the
That would be cotangent, but cotangent repeats
Yeah, I did.
every pi. Okay. So that's cotangent, right?
Yeah.
Here, let's go over it. Anyone close? Anyone need like just a few more seconds?
Oh, wait, we need to do the vertical.
It's pretty close. It's pretty close. All right. No, well, I'm not giving points for this one. Even if you gave it to me correctly, it's so difficult to graph, I don't know if I could judge it. All right, the pink graph is cotangent. Okay? We have a horizontal stretch by a factor of 2. That's why each of my blue lines span 2 periods of the pink lines. Okay? There's a vertical stretch by a factor of 3, which is difficult to see because the graph is only this big. And there's a vertical translation up 1 unit. So rather than hitting the x-axis, it's hitting about here.
So tangent has its like asymptotes at pi.
Cotangent has asymptotes at 0, pi, 2 pi. Tangent has asymptotes at all the halves. All right. Any questions on this one? I will leave it up there, yeah.
But if it has an asymptote at them, it can still pass over.
So this asymptote is for the pink lines, not for the blue lines. I only had one color highlighter. So
where's the asymptote? Oh, I see.
this one and this one. But because it's stretched, it's double the width.
Oh, so it has just like
As
the
your-
one versus.
Right. Mhm.
Oh.
All right. Does anyone need a few more seconds? You got it?
Sorry, but then the tangent has asymptotes at just pi at pi and 2 pi? Or the half?
The blue has asymptotes at 0 and 2 pi,
And the red?
and the pink has asymptotes every pi.
Oh,
So 0 pi.
so
2
not
pi.
the halves.
Not the halves. Oh, hold on. Shoot. Sorry, I was one off. Okay. I'm just gonna start over. Everyone had 3 to start. All right, anyone need a little bit more time? Yes. So it just continues on. I've turned the page here. All right. I'm going to go over this one as an example because it's very similar. So this one has a horizontal shrink by a factor of 1/2. So if you have fractions, you should end up with shrinks. You know what? I'm realizing I misspoke when I critiqued your last answer. Sorry. Because if it's a fraction, you do call it a shrink. If it's a stretch, it would be a whole number. Sorry. Completely nixed what I said earlier. And here would be the answer. So in this case, because it's a horizontal shrink, the graph is happening in double time. So the pink is tangent, and the blue is tangent of 2x. Yes?
Is it like a shrink by 1/2 because like the shrink formula is like so like 1 over
Yes, it's whatever is being divided here. In this case, x divided by 1/2 gives you 2x.
So if you have a fraction in the 4b, then it would be like a horizontal.
Then it would be a horizontal stretch, yes.
And not a fraction?
Yeah. Typically the horizontal stuff, it's the opposite.
Okay.
Whereas the vertical stuff, it's a little easier to see. Okay, it looks like we're not going to get to the last 2. I will extend the homework. There's most of the homework you should be able to do just fine, but there are a few questions on solving trig equations. Give it a try, but I'll extend it to the next class. All right. Have a wonderful day. Great job today. I'm sorry? So the 5A homework is being extended 1 class. But do as much as you can because I expect we'll finish both next class. It's just that the daily warm-up took a long time. Yes?
I'm gonna be
set this week for cheer. We're going to do this for our nationals.
All right. Let me stop recording.